What's up, guys? Take a second. Get comfy, because in today's video, we're diving into something that every backend developer, every API builder needs to know. Rate-limiting algorithms. Whether you're building out an API, locking down a login system, or just trying to keep bots from wrecking your platform, this right here is the stuff that keeps your app safe, smooth, and sane. What even is rate limiting? All right, let's start simple. What even is rate limiting? It's basically a way to control how many requests someone can make to your system within a set time frame. Like, maybe you only want to allow 100 requests per minute per user. It stops spam, it prevents abuse, and it makes sure everyone gets fair access to your system. Trust me, you will need it once your app starts picking up traffic. Without rate limiting, a single user could just blast your servers with requests, crash stuff, or run up your cloud bill like crazy. Plus, it's your first line of defense against DDoS attacks, brute force login attempts, API overuse. Rate limiting algorithms. Let's break down the main algorithms one by one. Super simple, super clear. 1. Token bucket algorithm. Imagine a bucket. It gets tokens added to it every second. Every time a user makes a request, it spends 1 token. If there are tokens in the bucket, the request is allowed. If the bucket's empty, nope, request denied. It's awesome because it allows bursts of traffic if tokens were saved up, but overall, it still limits how fast requests can flow in. Think of it like your data plan. You get 1 gigabytes per day, but if you didn't use yesterday's, you get to roll it over. 2. Leaky bucket algorithm. This one's a bit stricter. Now imagine the same bucket, but with a tiny hole at the bottom. Water, or in our case requests, drips out at a fixed rate. You can pour in as many requests as you want, but they'll only be processed slowly and steadily. If the bucket overflows, sorry, those extra requests just get dropped. Perfect if you want traffic to be super smooth and predictable. 3. Fixed window counter. This one's the easiest to understand. You break time into fixed blocks, like 1-minute windows. In each window, a user can make up to, say, 100 requests. Once the minute ends, count resets. Easy. But here's the catch. Users can sneak in 200 requests in just 2 seconds if they time it right at the window edges. That's called the boundary problem. 4. Sliding window log. This one's a bit more accurate. It keeps track of every single request's timestamp in a log. When a new request comes in, it checks how many were made in the last 60 seconds. If it's under the limit, it goes through. Super accurate, but uses more memory because you're basically keeping a full surveillance log of every request. 5. Sliding window counter. This one's like the best of both worlds. It checks the current window and the previous one, and then uses a weighted average to calculate how active the user's been. So if they made 30 requests in the last 30 seconds, and you're 50% into the new minute, it counts part of that past traffic in. That means smoother transitions, no sudden traffic spikes, and less complexity than a full log. It's clean.